Hello fellow YouTubers, I got my mount back from Austria. I'm so excited. Let's take a closer look at how to mount it and also how everything works. Follow along. I haven't given you a proper tour of my mount, the ASA DDM 85. There are three versions of this mount. There's the basic version, the standard version and the premium version. The premium version doesn't have the wedge. That one is supposed to be mounted on a custom specific pier. So the basic version has 45 kilos of payload capacity. The standard version, this one, has 65 kilos and the premium one has 100 kilos. But this is the standard version, 65 kilos of payload. I've been having this for about 6 or 7 years now. I recently got it back from a service and an upgrade. They took a look at the internal wiring, which goes into the back of the mount and through the axis and out on each side of the saddle plate. They also changed the bearings inside. Hopefully this will outlast me. This is my workhorse. Absolutely love it, and we're going to take a closer look at it today. As you can see here, this is a standard equatorial mount, which has basically the main function as any other equatorial mount. You have the adjustment screw for polar adjustment. This is the declination and this is the azimuth adjustment screws. On this particular mount, before you adjust those, you have to release the screws, which the bottom, the base is attached to the pier, and also these screw on the side here to be able to adjust the declination. When you are polar adjusting this one has no hand controller. This is only controlled via computer and the software called AutoSlew. It's a basic 3-star align. You choose to do polar align with that 3-star alignment. The software slews where the polar star is supposed to be, and then you adjust the mount back to that star with these adjustment screws. It doesn't have to be the polar star. Actually, it isn't supposed to be the polar star. The best practice to polar align this mount is to choose a star around 40-45 degrees above the horizon along the meridian. It's split into two. This is the base and this is the top part. These are the screws that the part is attached to. The counterweight shaft is a 60mm stainless steel. It weighs, I believe, 17 kilos, so a hefty part. I have the counterweight here. This is at 10 kilos, I presume. My first telescope mounted on this mount was too light, so I had to lay these down to just so thin that the threads still were visible to the lock screw here. With my new scope, my 10-inch carbon scope, I actually need 2 of these. Internal cabling, let's have a look at that one. We have 2 USB cables going in here. One of the cables is for the mount itself, to be able to control it. The other cable is to the USB hub. That is wired internally to 3 USB ports here. The other 2 cables one is for powering the mount itself. The motors in this mount has a peak amp drawage of 10 amps. The other cable is powering all the equipment. So I have one output here. I believe this is for a fan controller on the front of the saddle plate. And if I turn this around, you can see 3 more cables here. This is a 4-port cable. This is for all the 12-volt equipment, camera, focus motor, dew heaters, whatever you want to power. Connector in the middle here is quite interesting. You can, if you choose to, wire your own data cable. This port here, I'm not using it, but if you don't want to use USB for your cameras and such, you can actually use to wire a data cable yourself. Whether you use a Ethernet cable or whatever you want to choose, you can take that signal out of the saddle plate here. This port here is the same as the port on the other side. This is for a fan controller to cool down your telescope or whatever. I am using this is the back cover of my telescope. It has a fan here. I wired this one to a regular 5.5mm DC plug. The last bit, you'll probably notice this one. It's a reflective pad for my photo sensor, so the observatory roof cannot close without the mount being properly parked in a specific position. If you see this hex screw at the top here, this is for the clutches. When you mount your telescope, you don't want this to be so flimsy. You also have one clutch here for the right ascension axis. Total weight of this is almost 50 kilos, I believe 46 or 47 kilos. It isn't a mobile mount per se. You could mount this on a tripod, but it's heavy. The pointing accuracy is ridiculous. 0.02 arc seconds theoretically. The resolution is this one is quite good. I don't guide, never have been, probably won't do ever. This bad boy can hold his position very well. However, the main drawback of direct driven mounts is that you need to properly balance your telescope to a very, very precise degree. Once you have done that and it's completely weightless in every direction, it works absolutely fine. One comment I read on this mount is that, well, what happens if you have a power surge or electrical failure? Well, it stays put. If you have to balance it so darn good, it won't move. If the power goes, the telescope stays put. This button here is to activate the laser on the top of the mount. So you probably noticed there isn't any polar scope in the back here. On the Skywatcher mount and quite a lot of mounts, you have a polar scope going through the axis, or possibly mounted on the side of the mount. But this has no polar scope. So this button here activates a laser on top, so you can roughly align it to the Polaris. Quite nifty function, and because you do the polar line via the computer, taking picture and slewing from a star and adjusting mechanically the mount back to the star, you are precisely polar lined. So when you are roughly aligning these kind of mounts, activate the laser button and off you go. So have a great one out there. Please follow my channel, ask questions, hit the subscribe button, and continue to having a lovely summer out there.